Hey, Math 186 friends, finally back. Here's some more problems in 7.6, solving trigonometric equations. Make sure you watch part 1 and part 2 before you jump into part 3. I just have a handful here of more examples for you to follow through. If you have any questions, make sure you join me in Zoom. Keeping in mind, if my posted hours are not convenient, by all means send me an email and we can schedule a time to meet. All right, let's work on these problems. Let's solve the following equation. Solve 2 square root of 3 tangent of x equals 2. So in this case, we're not doing anything fancy with the tangent. It only appears once in the equation. It's not being squared or anything. So the key here is to isolate what we're solving for. So this is our equation. Let's get the tangent by itself, which is simple to do here. We can divide out the 2 square root of 3. So we get the tangent of x is equal to 2 over 2 square root of 3, which is just 1 over the square root of 3. So we can look at that as 1 over square root of 3, or we can rationalize the denominator, remembering that this is equivalent to the square root of 3 over 3, whichever you're more comfortable with. And remembering the values of the function of the angle whose tangent is square root of 3 over 3. So now this says to just generically solve. So if we don't see any restrictions on our solutions, we're looking for all possible solutions. So we are now looking for angles x whose tangent is the square root of 3 over 3. I know there's one angle in the first quadrant because the tangent is positive in the first quadrant, and then there's another angle in the third quadrant whose tangent is also square root of 3 over 3. And because I'm comfortable with my unit circle and my trig hand, 1 over the square root of 3 would be 30 degrees. So I know 30 degrees would be one angle whose tangent is square root of 3 over 3. And then the angle in the third quadrant that has the same reference angle, 30 degrees, right here. So one answer is 30 degrees. The other one would be this angle all the way around, which is our 210 degrees. So our two angles in 0 to 360 degrees, within the range 0 to 360 degrees, are 30 degrees and 210 degrees. So we would say 30 degrees plus all angles coterminal with 30 degrees. And then we would say 210 degrees plus all angles coterminal with 210 degrees. Now this is a perfectly acceptable answer. It's not completely simplified. And again, this is where it can get a little bit tricky. In Alex, I'm not sure how Alex is going to behave here. But if you notice, I'm going to go in with a different color here. If we look at our two terminal sides of the angles that go between 0 and 360 degrees, to get from one to the other, it's 180 degrees, and then it's another 180 degrees. So we can jump back and forth between our terminal sides just by adding 180 degrees each time. So we're going to rewrite this as, we usually pick the smaller of the angles, 30 degrees, and then we're just going to keep adding multiples of 160 degrees. In radians, just follow your directions in Alex. 30 degrees is pi over 6, 180 is pi. So that would be all solutions to the equation 2 square root of 3 tangent of x equals 2. If the question said to find all solutions to this equation, 2 square root of 3 tangent of x equals 2 in 0 to 2 pi, how would we handle that? Well, it's only looking for the angles within one rotation around, so it's going to be 30 degrees and 210 degrees, as we can see from our picture. But because our question was asked in radians, you should always answer in radians. So answer would be pi over 6 and 7 pi over 6. So look carefully if they give you a restriction on your solutions. If they give you a restriction on your solutions, you're only looking for answers within that interval. If they don't give you restrictions on your solutions, then you're looking for all possible angles that satisfy that equation. All right. Number 2, example 2 for today. Solve for cosine squared of x minus 2 equals 0. Well, again, this is the cosine only appears once, but it appears squared. So this is a step up from the next problem. What we're going to do is isolate the term, or isolate this piece right here. So we start with 4 cosine squared minus 2 equals 0. And then we're going to we add the 2 to both sides to get the cosine squared by itself. We get cosine squared of x equals 2 over 4, which is 1/2. So really what this comes down to is solving cosine squared equals 1/2. Right, we have to be careful here because it's not the cosine equals 1/2, it's the cosine squared equals 1/2. So to get the cosine by itself, we have to use the square root property. So at this point, keep in mind, when we have something squared equals a number, the square root property says that what we're squaring is either equal to the square root of the number, or what we're squaring the cosine here, is equal to the opposite of the square root of the number. So we can put this into more familiar form. 1 over the square root of 2, or square root of 2 over 2 if we rationalize the denominator. So we're looking for all angles. There's no restriction on our angle, so we're looking for all angles whose cosine is either square root of 2 over 2 or negative 2, square root of 2 over 2. All right, if we look at this guy, I kind of like this because then I can think of my trig hand. And angles whose cosine is square root of 2 over 2 is going to be, sorry, wrong finger. It's going to be square root of 2 over 2 is going to be 45 degrees. Plus all angles coterminal with 45 degrees. But the cosine also equals the cosine of the angle in the fourth quadrant. All right, backpedal. There is an angle in the fourth quadrant whose cosine is also equal to square root of 2 over 2, and that's the angle in the fourth quadrant with reference angle 45 degrees, so 315 degrees. Also has cosine square root of 2 over 2. Now this is nice because we see the square root of 2 over 2 over here also, but just negative in value. So we're now going to look in quadrant 2 and quadrant 3. So the angle in quadrant 2 that has cosine negative square root of 2 over 2 is 135 degrees, same reference angle as 45 degrees. And all angles coterminal with it. And then we have the angle in the third quadrant whose cosine is negative square root of 2 over 2, 225 degrees, plus all angles coterminal with 225 degrees. Okay, so now let's see, we're going to draw a picture to see if we can condense that. I'm going to draw these 4 angles. All right, so our first one is 45 degrees. All right, our next angle over here is going to be 45 degrees, and then we're going to have 135 degrees. And then we're going to go over here. We're going to be at 225 degrees. And then our last one over here, we're going to make it all the way around, and that's going to be 315 degrees. Okay, again, this answer is not incorrect, but there is a nicer, more condensed way to look at this, because if we look at the terminal sides of the 4 solutions between 0 and 360 degrees, and we look at the angle measure between them, we can get from 45 to 135 by adding just 90 degrees. We can get from 135 to 225 degrees by adding 90 degrees. We can get from 225 to 315 by adding 90 degrees. And we can get from 315 back to all angles coterminal with 45 by adding 90 degrees to each time. So because this remains consistent between the solutions, we can rewrite our answer. Well, we could start at 45 degrees and just keep adding multiples of 90. 90, 180, 270, 360. In radians, pi over 4 plus 90 degrees is pi over 2. Okay. So cool little problem. Practice with that. If you have any questions or you want to go over more of these, by all means, let me know. All right, let's take it up a little bit. Two more examples for you. Find all solutions to 6 tangent squared theta minus 2 square root of 3 tangent equals 0. Let's add in the interval from 0 to 360 degrees. All right, so we'll do that right from the beginning this time. All right, so this one is yet another step up because our unknown angle appears inside a trig function that appears twice in our equation. What we think here, when you see this unknown appear twice inside our trig equation, so the trig function appears twice, think factoring. We like the zero product principle. The zero product principle says that if you have a product that equals 0, then one of the factors must equal 0. So we like to turn sums and differences into products if possible. So what I look here is for common factors. They both share a common factor in the coefficient of 2, and then they both share a tangent. So notice if we pull out 2 and tangent of theta, what's left is, well, here we're going to have 3, and we have 1 tangent left. And then here we're just going to have, we took out the 2 and the tangent of theta, so we're going to have the square root of 3 left over. So let's just multiply it back through. 2 tangent theta times 3 tangent theta is 6 tangent squared of theta. 2 tangent theta times the square root of 3 is 2 square root of 3 tangent of theta. So what we did was we turned this difference into a product. Now we can use the zero product principle. The zero product principle says if you have a product that equals 0, then one of the factors has to equal 0. So either 2 tangent of theta equals 0, or this entire factor, 3 tangent of theta minus the square root of 3 equals 0. So now we're going to look for all solutions to these two smaller equations that fall within one rotation, 0 to 360. So I can divide the 2 out. So this is just equivalent to finding where does the tangent of theta equal 0. And we know the tangent equals 0 when the numerator, when we think of the tangent as the sine over the cosine. So it's when the sine is 0. So any angle that lands on the x-axis has a tangent equal to 0. So 0 degrees and 180 degrees. Now we're not going to keep going past, I guess 360 would be one also because that's in our interval. So, and then we would be back at 360. So at both endpoints of the interval, the tangent would equal 0. Thus this whole equation would be solved. And also at 180 degrees. So this little equation gives me the solution 0 degrees, 180 degrees, and 360 degrees. All right, over here we have to do a little bit more work. We have to isolate the tangent. So this is equivalent to 3 tangent of theta equals the square root of 3. Tangent of theta equals the square root of 3 over 3. So now we have to be comfortable with our tangent function. Where does the tangent equal square root of 3 over 3? Well, I'm good with my unit circle, so I know it's going to be at 30 degrees. And then tangent's also positive in the third quadrant. So it's going to be the angle with reference angle 30 degrees. So this angle right here, which is 210 degrees. Now we don't have to worry about the adding the 360K because it is only looking for angles whose answers are between 0 and 360. So my solutions are, whoops, lost my train of thought, 30 degrees and 210 degrees. So let's put it all together. All solutions. I like to just put them in order. 0, 30 degrees, 180 comes next, 210 is my fourth angle, 360 is my final answer. Okay, so if you see any questions or concerns, by all means, if you see any mistakes also, bring that to my attention, and I'll be happy to send an email out to the class for anybody who has watched the video. I am doing my best not to make mistakes. All right, last example, and then you can get to work. Solve 2 sine of 3x equals -1. Right, what makes this different and a little more difficult is the fact that we have a coefficient in front of the variable inside the trig function. So we have to be really super careful here. So how do we go about this? Well, I kind of think of this, there's different ways to go about this. You can see how Alex does it. They use a process called substitution. I guess we can do that. This is an angle, so let's call this theta. So let's let theta equal 3x, because we're always taking the sine of angles, so I'm going to force 3x to be the Greek letter theta. Now we're really solving 2 sine of theta equals -1. And by taking 3x and replacing it with theta, we get a problem that's much more simple and obvious to solve. So to solve here, we're going to isolate the sine. So this is equivalent to solving the sine of theta equals -1/2. And notice there's no restrictions. It doesn't say just between 0 and 360. So we're looking for all angles whose sine is -1/2. So that must be angles in the third and fourth quadrant. Sine -1/2 would be angles whose reference angle is 30 degrees. So 30 degrees. And then this guy over here, 30 degrees. So we're looking at this first angle, which would be 210. And then if we go all the way around, we're going to be at 330 degrees. So now here's where it gets a little tricky, because what we did is we just found the angles theta. Theta is equal to 210 degrees plus all multiples of 360, or all angles coterminal with 210 degrees. And theta is also equal to 330 plus all multiples of 360 degrees, or equivalently. Now we look to see if we can condense this, and this is a good example to show that it doesn't always work out. Here's my initial side of my angles. Here's the first terminal side. Here's the second terminal side. And if I look at how we can get from one terminal side to the next, the difference between here and here is 120 degrees. But the difference between that terminal side and if we get back to the next one is definitely not, 240 degrees? It's definitely not 120 degrees. So we cannot condense this at all because the difference between the terminal sides does not remain constant from one to the other. So we're stuck here. Although this is not the solution, because we found the solution to this equation, we started with this. So you have to keep in mind that we let theta equal 3x. So keep this in mind. And now what we're going to do is go back down here and replace theta with 3x. So if we let theta, which is equal to 3x, equals 210 degrees plus 360k, divide the 3 out of both sides, everything on both sides. All right, so we're going to eliminate the theta. We're solving just for x now. X is equal to, well, 210 over 3 is 70 degrees, plus 360 over 3 is 120 degrees. So this solution, when theta is equal to 210 and all angles coterminal with 210, that's equivalent to 70 degrees plus all multiples of 120 plus 70 degrees. This is going to give you 3 angles between 0 and 360 that's going to solve our original equation. So now let's go back to the second one, 3x equals 330 degrees plus 360k. But we're going to divide everything by 3. No longer looking at this in terms of theta, we're going to solve it for x. We're going to get x is equal to 110, and then do 360 divided by 3 plus 120k. So I promise you, if you take 110 at any multiple of 120, say you did 3 times 120, well, if you did that, you'd be coterminal with that, but let's say you had 2 times 120, 240, and you added that and you plugged it back into the original, you would get a solution to the original equation. So therefore, my final answer, solutions, x is equal to 70 degrees plus 120 degrees k, or x is equal to 110 degrees plus 120k. All right, what about radians? Right, this looks horrible to put into radians because we don't know nice radian measures off the top of our head for 70 degrees and 110. So what I suggest is you go back up here and you work from this. So before you divide the 3 out, let's write 3x in terms of radians. 210 degrees is the same thing as 7 pi over 6 because it's 7 times 30 plus 2 pi k. Now we're going to divide both sides by 3, but remembering dividing by 3 is the same thing as multiplying by 1/3. So I'm going to multiply each side by 1/3. And I'm going to get x is equal to 7 pi over 18 plus 2 pi over 3k. So 7 pi over 18 is equivalent to 70 degrees, and 2 pi over 3 is equivalent to 120 degrees. So let's just do the other one. We had 3x is equal to 330 degrees plus 360k. I think it's a lot easier, on occasion, it's a lot easier to, turn it into radians. Let's listen to follow my own rules. 3x is, 330 is 11 pi over 6, because 11 times 30 degrees, plus 2 pi k. Now let's multiply both sides by 1/3. Take 1/3 of each piece of the right side, and we get x is equal to 11 pi over 18 plus 2 pi over 3. Okay, so therefore answer, we started with x equals 70 degrees plus 120k, and we got x is equal to 110 degrees plus 120k, or in radians. So just make sure you follow your directions in Alex. We have 7 pi over 18 plus 2 pi over 3k. You are welcome to use your templates to convert from degrees to radians at this point if you find that easier. This is going to be 11 pi over 18 plus 2 pi over 3k. And there we go. So I'm sure I have problems somewhere for you to do. And this will end your chapter 6 material. Nope, chapter 7. 7.6. I removed 7.7 from your objectives in Alex. I thought the problems were sort of beyond the scope of what we needed to do this semester, especially based on the circumstances. So if you notice, your problems went from 36 down to 32, and that is correct. If you are still having problems seeing your grade book, make sure you go into reports instead in your drop-down menu, and you can see where you stand. Exercises in 7.6 in the text. Look at 11, and then 29 to 63 odd. If you want even answers, feel free to send me a message, and I'll be happy to provide you the even answers. Alex, You should now do all of chapter 7. 60% for tonight. And you want to get it all done for next Wednesday. All right. Hope everyone's having a great time and staying safe and enjoying not getting up too early in the morning. Please, please, please be sure to contact me if you have any questions, comments, or concerns, okay? Be back in touch soon. Bye.